In this video, I'm going to be explaining how to complete Activity 7. Before we get into the directions, I need to give you some background information about the topic that we're applying in this video. If you're doing an experiment and you're randomly assigning participants to two groups, it's important to have a large enough sample size. It's important to have a large enough sample size so that you're confident that the groups are similar enough to each other. You don't want to use a very small sample size, like 4 people. If you took 4 people and you randomly assigned them to two groups of 2, you're at a high level of risk for creating two highly unequal groups. You could easily get two groups that are highly unequal. For example, you might get 2 younger people in one group and 2 older people in another group. Or you might get 2 males in one group and 2 females in the other group. So if you used a very small sample size, like 4 people, you're at a high level of risk for creating two highly unequal groups that can't be fairly compared, like 2 younger people and 2 older people, or 2 males and 2 females. If you're randomly assigning participants to two groups, a rough guideline is for you to have 50 people per group, or a total of 100. If you like, I could share the table that shows that guideline. But what if you couldn't get a sample size of 100? What if you were stuck using a small sample size? What if you simply couldn't get enough participants to meet the guideline of 100 people? What would you do? Well, in that situation, when you're stuck with a small sample size, you could do something called a matched pairs design. In a matched pairs design, you do something called matching, which helps to make up for the small sample size. When you do matching, you actually force the groups to be equal on certain characteristics, and that helps to increase your confidence that the groups are highly equal to each other, despite the small sample size. So if I was stuck with 10 people and I was randomly assigning them to two groups of 5, 5 and 5, I'm not confident that the groups are highly similar to each other, right? Because there could easily be some differences just by chance, right? But if I use matching, I can force those two groups to be more equal to each other, and that will increase my confidence that the groups are actually equal on important traits, right? So how do you do matching in a matched pairs design? Well, first you have to pick something called a matching variable. The matching variable is what you want the two groups to be equal on. It's some important characteristic that you want the groups to be equal on. So imagine I'm doing a memory experiment, and I'm randomly assigning my participants to a cold room and a hot room, and I want to look at the effect of temperature on recall. In that experiment, I might want to ensure that the two groups are equal in how much sleep they had the night before, right? Because obviously I don't want the hot room to all be tired and the cold room to all be well rested, because then I can't fairly compare them. If I decided that I want to force the two groups to be equal on sleep, I could I could use hours of sleep as my matching variable. And what I would do is, before the experiment, I would give a survey and I would ask each participant for how much sleep they had the night before, and I would use their answers to actually force the two groups to be equal on hours of sleep. I wouldn't be depending on just random assignment to make the groups equal in sleep. Or let's say I decided that I want the two groups to be equal in age. Well, I could make age my matching variable, and I would record each participant's age at the beginning of the study, and I would force the two groups to be equal in age. And you don't have to use just one matching variable. It's possible to use 2 or even 3 matching variables. For example, in my experiment, I might decide that I want the groups to be equal on age, sleep, and some other characteristic like general recall ability. Well, I could record all 3 of those traits at the beginning of the study and force the groups to be equal on all 3 of them. But in the simplest matched pairs design, you just pick one matching variable and you force the groups to be equal on that one variable. In this activity, we're just going to do the most simple type of matched pairs design, in which we just pick one matching variable. And ensure that the groups are equal on that variable. And before we get to the directions, I wanted to mention that we've already talked about matching before. We talked about matching in the context of a non-equivalent groups design. We learned that when a person is doing a non-equivalent groups design and they're comparing two naturally existing groups of people, like two classrooms, the person might want to create matched pairs that are similar to each other so that they can compare the two people within each matched pair, right? Um, but in this activity, we're actually learning about how matching can be done within the context of a true experiment with random assignment. Because matching doesn't have to be just done in a quasi experiment, it could also be done in a true experiment if the sample size is too small. So if the sample size is small and random assignment alone isn't very effective. So let me get into the directions here. So you're imagining that you're doing a recall experiment, and at the beginning of the experiment, you've recorded these three extraneous variables. An extraneous variable is a variable that's not being studied, but could affect the data. So if you were doing a memory experiment and you're comparing, let's say, a hot room and a cold room, these variables would all be extraneous variables because you're not studying the impact of these variables. You're only studying the impact of temperature, right? And you don't have a hypothesis about any of these variables, but these variables could still impact the recall scores of your participants. So they're extraneous variables. The word extraneous means irrelevant or outside of the focus of something. So an extraneous variable is basically just something that's not being studied, but it's a threat to your experiment. So what you need to do is pick one of the three extraneous variables and select it as your matching variable. And you can pick any one of them, but you have to pick just one of them. So what I want you to do is think about which variable would you want to ensure that the two groups are equal on. If you want to ensure that the two groups are equal in age, you would pick age. If you want to ensure that the two groups are equal in height, you would pick height. Or if you want to ensure that the two groups are equal in hours of sleep, you would pick hours of sleep. So just pick the one that you think is most important. Now, in an actual study, you would look back at earlier studies to get an idea of which one is most important. You wouldn't just take a guess. But in this exercise, I just want you to just take a guess at which one you think is most important. So let's say you decide to pick hours of sleep as your matching variable. What you're going to do now is put hours of sleep here, just write hours of sleep, and write hours of sleep right here. And next what you have to do is create your matched pairs. So what you have to do is create pairs of people that are highly similar on hours of sleep, because that's my matching variable. It's the one I decided to pick. So 3 and 3 would go together. It looks like that's person 1 and person 1, 2, 3, 4, 5. So what I would do here is I would write a 1 and I would write a 5, saying that this is person 1 and person 5. And I would write their scores on the matching variable, which are 3 hours, 3 hours. So it would be 1, 5, 3, 3. Then I would move on to my next pair. And it looks like the next pair would be 5 and 5, which is person 8 and person 10. So I would put 8, 10 for my ID numbers, and I would put 5 and 5 for my matching variable scores, hours of sleep. Then I would go on and I would create my last 3 matched pairs. So just continue the process that I've been describing. And it's okay if one of your pairs isn't perfectly equal. So if one of your pairs has to end up being a 6 and a 7, that's fine. What I recommend doing is putting your matching variable scores in order from lowest to highest, and then just create pairs as you go up the list. So remember, you have ID numbers and you have your matching variable scores. So matching variable scores go here and matching variable scores go here. Once you've created your matched pairs, you need to randomly assign your participants one pair at a time. So the two conditions are going to be the ascending presentation and the random presentation, which are the same conditions from our last activity. It's the same recall experiment. So what you need to do is in each pair, randomly assign one person to ascending and one person to random. And to do that, you need to do a series of coin tosses. You need to do 5 coin tosses, one for each pair. And you need to record the outcomes of your coin tosses on this sheet right here. So let's say you flip the first coin and it lands on heads. You would write heads right here. And if it's heads, that means that the left person in the pair goes to group 1 and the right person goes to group 2, which in this pair would mean person 1 on the left goes to ascending, person 5 on the right goes to random. And let's say that this ended up being tails for pair 2. Well, that would mean in your second pair, the right person goes to group 1, ascending, and the left person goes to group 2, random. It's just reversed. So write all of your coin tosses right here. Then write the ID numbers of your participants in the ascending group and the random group. So if this was heads, this is the left person and this is the right person. If this is tails, then this is actually the right person and this is the left person. And if this is heads, it's the left person and the right person again. So just fill in the ID numbers from the previous page and fill in your matching variable scores. They're going to be the same. Uh, if you're doing hours of sleep, it's going to be 3 and 3 for your first pair again. And I believe the next one was 5 and 5. So 5, 5. And just keep filling in your matching variable scores. MV means matching variable. So these are all matching variable scores. These are all matching variable scores. Now what we need to do is fill in the actual recall scores from the experiment. So once the experiment is done, each person will have a recall score. So just make up each person's recall score. Um, make up a number between 0 and 10. No, I'm sorry, 0 and 12 for each person. I think that's what I said in my directions. Let's go back up here. No, I didn't specifically say, but just make it between 0 and 12. Let's imagine we're asking each person to memorize 12 items, and each person's score can be between 0 and 12. But when you make up each person's recall score, give some thought to how you think that person would have performed in his or her situation. So take into consideration both the hours of sleep the person had and the list that they're memorizing. If the person is sleep deprived and they're also memorizing the random list, they're probably going to do pretty poorly because they're tired and it's a hard list. If they got a full night's sleep and they're memorizing the ascending list, they're probably going to do pretty well. And if they're well rested and memorizing the random list, they might get sort of a middle range score, right? Because they're alert, but they're memorizing a hard list. So just take those factors into account and make up your 10 recall scores. And then once you've made up your data, calculate the mean of your matching variable by adding these numbers and dividing by 5. Do the same thing for group 2 random. Calculate the mean recall score by adding and dividing by 5, and do the same thing for group 2, and write the 4 answers down here. Once you've done that, you should see that your two groups are equal, or at least highly equal on the matching variable. So this mean right here and this mean right here should be pretty equal because that's what the matching was meant to do. The matching was meant to ensure that the groups are equal on the matching variable. If the two matching variable means aren't highly equal, go back and check because you might have made a error somewhere. Now the two recall scores, I'm sorry, the two mean recall scores for ascending and random probably won't be equal, and that's fine because um, obviously ascending is probably going to do better than random. That's the hypothesis. It's just the matching variable that's supposed to be equal between the groups because that's what you're trying to control with the matching. So once you've done that, create a scatter plot of your dependent variable and your matching variable. So to do this, you're going to have to take the 10 matching variable scores from this page and the 10 recall scores from this page, which you made up. So um, remember, you have 10 people in the experiment, 5 people per group, and each person has both a matching variable score and a recall score. Each person has 2 numbers. You're going to take each person's 2 numbers and make a scatter plot for all 10 people. So your scatter plot will have 10 dots altogether. So fill in the name of your matching variable right here, whichever one you happen to choose, either hours of sleep, age, or height. Put recall right here because that's our dependent variable. And then make some tick marks down here for your matching variable. And make some tick marks here for your dependent variable, which is recall. I would just go from 0 up to 12. And then plot a dot for each person's 2 numbers. So if this is person 1 right here, then that person's matching variable score would be down here, and their recall would be over here to the right. Once you make the 12 dots, the 10 dots, look to see if you have a correlation, a strong correlation in the scatter plot. If you see a strong correlation and the dots hug the line pretty closely overall, then that means that you picked a good matching variable. If it's a weak correlation and the dots are all over the place, then you didn't pick a good matching variable. Now, the correlation could be a strong positive or a strong negative. Either way, you picked a good matching variable. So if the dots are closely hugging a rising line, you have a strong positive and you have a good matching variable. If the dots closely hug a dropping line, you have a strong negative and you have a good matching variable. But if the dots are all over the place and it's a weak correlation, you don't have a good matching variable. You didn't make a good choice. So for for this activity, I'll just have you look at the scatter plot and just visually decide if it's a strong correlation or not. But if you're having trouble deciding just based on the scatter plot, I would recommend going online to a correlation coefficient calculator and actually calculating the correlation coefficient. And if it comes out to 0.7 or higher, then you have a strong correlation, and you can say that it's a good matching variable. But I'm just going to have you go by the scatter plot for this activity. Before I get to the follow-up questions, I'll just give a quick simple explanation of why this correlation matters between the matching variable and the dependent variable. If the matching variable and dependent variable are strongly correlated, it shows that the matching variable has something to do with the dependent variable, right? So if your matching variable is hours of sleep and your dependent variable is recall, and you see a correlation here, then what that's saying is that hours of sleep and recall are actually connected. The people who were sleep deprived are actually doing more poorly, and the people who are well rested are actually doing better. And that shows that that the matching variable was a good idea because it actually is connected with your dependent variable. But if the line is flat and the people who were tired are doing just as well as the people who are well rested, then that means, well, who cares if the two groups were equal in sleep, because the tired people are doing just as well. And in that situation, you would say, I didn't pick a good matching variable. I picked an irrelevant matching variable, and I should have picked something more relevant, basically. That's the idea. So here, after you do that scatter plot, do the follow-up questions. This question says, what happened after you randomly assigned your participants? Were the two groups exactly equal, roughly equal, or highly different on the matching variable? Well, you have to go here and look at the two mean scores on the matching variable for ascending and random. If you did the matching well, they should be equal or roughly equal because that's what the matching is supposed to do. And then here, decide if you picked a good matching variable and explain why or why not. And you have to look back at your scatter plot here to make the decision. And after that, you're finished with the activity because I'm not going to have you answer any questions on the whiteboard because, well, I'm just going to skip that to keep things simple for this activity, or more simple.